Okay, here we have a couple trig identity questions. It's not really saying prove left side equals right side, but it is saying to simplify these into something simpler, like simplifying means. So I'm just going to take a look at number one here. We're always looking for squared trig ratios because those are the ones we can use our Pythagoras identities to actually, substitute something else in for them, at which point we can then either factor and cancel or reduce, things like that. So when I look at this number one, I'm keying in on sine squared x because that is a squared trig ratio. I know sine squared x equals 1 minus cos squared x over 1 plus cos x. And now we should see, 1 minus cos squared x, that can be thought of as a difference of squares. So I have the 1 minus, and then difference of squares does 1 minus the square root and 1 plus the square root. So we should know how that works. But in case you don't, you should be able to see that if we were to multiply these brackets back out, we would get, the middle terms would cancel when we FOIL, and we'd get back to 1 minus cos squared x. And the beauty of this is that we can now cancel 1 plus cos x and 1 plus cos x. So we're left with 1 minus cos x, which equals 1 minus 1 plus cos x, which is just cos x. Okay, so what looked like a fairly complex function or expression actually comes down all the way just to cos x. Now let's look at the second one. Seems like a lot more is going on. From an operation standpoint, we've got a bracket times another bracket and then minus two other terms. So we can't really do anything with those minus two terms until we expand our bracket. So I'm just going to FOIL these out or multiply them out. So I get sine x times secant x plus the outside terms will be sine x times cosecant x plus the middle terms will be cos x times secant x, and the last terms will be plus cos x times cosecant x. And then I still have my minus cot x and my minus 2 hanging out. So lots going on, but it really helps if we know what these reciprocal functions are. So I'm going to write them out as that. So it's sine x times secant x is 1 over cos x plus sine x times 1 over sine x. So that looks really helpful there because those two multiplied will cancel to 1. Plus cos x times secant x once again is 1 over cos x. So that will again be helpful when we have cos x times cos x on the bottom. Plus cos x times 1 over sine x. And I'm going to keep this as cotangent x minus 2. Try and keep everything on one page here. So with this first term now we get sine x, I'll go back to red, sine x times 1 over cos x is sine x over cos x, which is tan x. So I'm going to keep it like that for now. Plus 1, because these sine x's cancel, plus another 1, because these cos x's cancel, plus cos x over sine x from this term here, which is cotangent x. It's important to think of cotangent x as not only 1 over tan, but as the reciprocal of what tan stands for, which is sine over cos. So we think of cotangent as cos over sine. And then we have our minus cotangent x and our minus 2. Simplify this, we get tan x plus 1 is plus 2, plus cotangent x minus cotangent x, so those cancel. And we're also left with the minus 2 hanging on at the back. So tan x plus 2 minus 2 just equals tan x. So if you keep going and simplify these things correctly, it takes a fairly complex expression down to one single trigonometric ratio. Again, it'll take some time to practice, but once you get the hang of what these reciprocal functions stand for, so secant x, cosecant x, and even cotangent x, it really helps to be able to sort of predict what's going to happen as you're simplifying your identities. So hopefully that was helpful. You can always send us more questions or check out arnoldtutoring.com. Thanks.